Okay. We usually begin with like a brief background of yourself and how you got into your field.
Yeah, so I guess am I starting?
Yeah, you can just start by giving us a brief background of yourself and how you got into your field.
Hi, I'm Aditya, and basically I'm a robotics engineer. I was just doing my master's in RoMeLa. It's in UCLA. It's a robotics and mechanisms laboratory where I was working on a humanoid robot. So let me just share screen. Oh,
Oh, sorry. One second. Let me enable screen share. Okay, you should be able to now.
so like So Vecdrive is basically a company that I'm working right now for. So it's basically a company that I'm doing with my friends. Uh, but more or less, so Vecdrive. So basically, these are robots that we were working on before we started this company, and these robots. This is called Artemis. It's a humanoid robot which was made to play soccer, and I was part of the team which was supposed to be organizing or like which was supposed to be participating for this competition. So the competition was called RoboCup, where it's basically autonomous humanoid soccer playing competition, where you had a two versus two completely autonomous humanoid robots who are supposed to follow all the rules and play soccer. So I can show you some videos for that. Sorry, I don't have any presentation ready, but I think
That's okay.
this was like our final match that we.
Yeah, go Team RoMeLa! Yeah! Woo!
So these two are our
Let's do
robots,
this!
and as you can see, we are not allowed to touch the robots or like give any commands or anything. Everything was autonomous. The people that you see in the background are just because uh, if in case the robot falls or if there's an emergency, just to avoid that. But other than that, this whole thing is completely autonomous. So as you can see, like the whole robot is planning and going and trying to figure out where the ball is. So it has like a camera which detects where the ball is, and then there's a path planning algorithm which like takes it to the ball, and basically it's supposed to go and shoot.
That's really cool. Can you give us some background as to how you got into robotics and what made you want to study it?
So when I was in my undergrad, basically, like I was kind of always curious about robotics, and so I kind of started taking up some courses, and like I got to learn something. Like I started my journey with basically trying to like figure out how like the robotic arms, which we call manipulators, work. Like my first project in my undergrad was to make my own manipulator. I guess that's where I really got interested in robotics. And then I was applying for my master's in the US. And I came across UCLA and I found out this lab, RoMeLa. And I was like, oh, yeah, that looks cool. Let's try going there. And luckily, I was able to join the lab and we were able to do, or at least I was able to work into robotics and like do really cool stuff.
Yeah, that's really interesting. So, everyone else in the meeting, you can start typing your questions in the chat and I'll just read them out loud. Until then, do you want to tell us about any other fun projects you've been doing other than the robotics soccer player?
So the other fun project we had was one sec, where is that? It's in the So this was another fun project which we called LIMS, or Latching Intelligent Modular Mobility System. So this was like a robotic arm, but without a fixed base. So this was a funded project by LG, and the challenge for this project was basically the problem for this was that if we have an autonomous vehicle or like an Amazon autonomous truck which comes to the front of your house, how do you deliver the boxes from the truck to the front of the house without any human help? And so we came up with this idea of this manipulator where it's basically going to, like, as you can see in the sequence, like there are two manipulators which are attached to like the ceiling or the wall of the truck, and they will come and attach to the box. And so basically, and they'll detach themselves from these walls, and so eventually you'll have four manipulators which are attached to the box, and they basically become the arm of the box, oh sorry, legs of the box. And basically they'll just walk out of the truck, and they'll just go keep the box. All the four arms will basically detach themselves, and then they'll just come back into the truck. Like the way they can come back, this was just one of the ideas of how we thought it could come back. Uh, I don't think I have videos for this one, but yeah, we did have a prototype made. Maybe there is one on YouTube. Yeah, this one. Yeah. Yeah, I don't think I have any videos, but these are like all the other robots from our labs. That's how we basically developed stuff. So these robots were there before I even joined the lab, but this is like how the research progressed, and that was the project that I came and joined into.
So do you remember a time where you had to work through a struggle while creating these robots, and how did you push through that?
I think I think during the competition, like the whole time was a struggle, because I think so. The robot competition, we basically went, at least while I was there, we went twice. So it was in 2023, we went to France, Bordeaux, and that was a terrible year for us because I think we all just got, so a lot of senior members of the lab had left, and a lot of responsibilities had fallen on like me and three other more fellows. And for me, I was pretty new, so I think trying to learn everything at that time, and we were trying to build up another robot. So it was really stressful trying to figure out how things work. There was a lot of things that I didn't know, but I was basically just like showing up every day is what I would say was the key. And I think even this year for 2024, the competition was, so the one in France, we lost pretty badly. I think we ended up like, so there were only four teams, and we ended up third place. Uh, and nothing basically worked over there. Like our whole code was like you could find some videos online if you just search RoboCup France, and you will see like how we were struggling. Like a robot was not even following where the ball is; it kept going anywhere. And so again, we got back next year, and I think like I remember our working hours used to be like 4 p.m. to like 5 a.m. every day, because that was the only time when we were allowed to like test our stuff and get an actual field during the nights when there was nobody on campus. And basically, yeah, just showing up every day. I think having a team really helped. We tried helping out each other wherever we were stuck, and yeah, just trying to keep being motivated.
That does sound really difficult, especially the working hours. Now that you're not in a competition right now, are the working hours a little bit better?
Uh, so depends. I think some of my friends who are at Tesla, I think they're still struggling with the working hours. For me, I just finished graduation and like I just moved back, so I'm kind of taking it chill for now. But I think me and some of my friends are trying to do a startup, so I assume the working hours would go bad again. But yeah, we'll see about that.
Yeah, and I have a question from the chat. What advice
Yeah.
would you give to someone trying to enter the robotics field?
I guess the biggest advice I would give is uh, make sure you're really interested in robotics. Like, I think there are ways you can find out by doing like small projects, like just doing online Arduino based projects, just like trying to do a line following robot and figuring out how simple things work. The second thing is, I feel like a lot of people who I saw who came trying to do robotics, I think the biggest issue was robotics is a vast field. I think there are many subsections to robotics. It's like either there is design related stuff, there is electronics related stuff, there's like motor related stuff, and then there's like software related stuff. Even in software, I think there are a lot more subsections of like, oh, do you just want to do controls, which is like low level control of figuring out how the motors work and communicate, or if you want to do like high level planning stuff. I think it's nice to like kind of get an idea. I mean, I'm saying you should try and explore, but I think you shouldn't be like, oh, I want to learn everything. I would rather say like try focusing your time on the one thing that you really like out of that field and try growing there rather than trying to do everything. Like I saw a lot of undergrads or graduate students who joined the lab, and the first day they were like, oh, can you guys teach me how this robot walks? And then it was like, oh, but do you have any coding skills? Oh, do you have any control skills? And most of them said no. So I think the important thing is like trying to start from small stuff, trying to figure out some small projects before like just trying to jump into trying to do something complicated.
Yeah, that is really good advice. Could you tell us a little bit more about the education you went through, like your undergrad and your master's and what you took?
So my undergrad was so I did my undergrad back in India, and I was in Triple IT Chennai. So I just did my undergrad in mechanical engineering, but I did have some courses where I had like a one or two robotics courses, and also like I did an internship during my undergrad, which was in robotics. So I think I had a lot of opportunities in my undergrad, which kind of inclined me to do robotics. And then based on that, I decided to pursue my master's at UCLA. And I think more than doing the courses, I think joining RoMeLa was what really helped me to like get into robotics, because I think you can read a lot online or like try to do as many courses as you want. But at the end of the day, I think unless you actually build yourself something and actually try and implement stuff, you don't really get good at stuff. Like there are a lot of small little things that no book teaches you or like no course will teach you. A lot of them will just be telling you a lot of high level stuff. But I think actually when you start implementing stuff, you get to realize the hurdles, and that's when you try to get to learn more and more.
Yeah, I think in the field work really matters a lot. Do you have any specific jobs that you've been to that may be really good for robotics and may made the field better?
Uh, so I haven't done a job really till now. I guess I've been lucky or unlucky in some ways, I guess, because I like during my undergrad, I just did an internship once, but that was also like a research internship, which was I wouldn't really say like a job. I think robotics as a field right now is evolving a lot more to actually have real jobs. I think in next 3 or 4 more years, I think there will be lot more legitimate jobs, I would say, in this field. I think every company right now is just trying to like research some product, develop some product, and it's everybody is in a race to kind of get something out. So I think the field right now is competitive in a lot of ways, but also like very research based. Like I have some friends who work in Tesla, like on the Optimus robot. You guys might have seen or not seen, I don't know. But yeah, I think the field over there is, I mean, the people over there are trying to like, it's what I've heard is it's the same thing or the same experience that I've had in lab. And it's just like a research platform that they're trying to figure out how things work.
Yeah, I have heard that the robotics and engineering field in general is really competitive. Is there
Yeah.
anything else that brought you to America for your major other than the robotics program at UCLA?
Um, I think the reason I wanted to come to America was I think in a lot of ways the research that was going there was much more advanced than that was happening here in at least in the field. I think the field is very new right now, so I think a lot of research funding is available in the US compared to any other country for people to do research. I think that was like a big motivation for me to come there and try to bring something back and try to do something of my own.
I think you did kind of answer that top question already, but what are some tips you can give us high schoolers wanting to go into robotics?
Uh, I mean, I would say, yeah, just, try to search online and try to do like some simple robotics projects. I think nowadays there are a lot more robotics projects available. Like you can just, take an Arduino, try to come out, like just take an Arduino, put four wheels on it, see if you can just like able to control it, or if you want, you can try designing something yourself. I think there are a lot more easier drone related projects that you could try. Or there are also a lot of simple 3D printed arms that you guys want. You can try. Basically depends again, like are you guys more interested in the software side or in the hardware side? I guess based on that, I don't know how much software or coding experience have you guys had till now, but if you guys do enjoy doing software, I think there are a lot of software projects out there that you could just give it a try.
Yeah, and if you had a choice, what robotics project would you like to be a part of?
I think if I had a choice, I definitely would be a part of a humanoid robotics project. But I think there's a lot you need to learn to get to that point because one, I think there are not a lot of people who know about humanoid robots right now. I think everybody's just trying to learn and figure things out, as I said. And I think secondly, I even though everybody is doing a humanoid these days, and you see like so many companies trying to post videos on YouTube, like I don't know how sustainable of a job that is because one, humanoids require a lot of money in like research and development, and unless the company you're employed in basically has very deep pockets, it's kind of a gamble to like take up a job in the humanoid robotics field because the company could very easily run out of money and then you might be out of a job the next day.
Do you think AI will be or is already a big part of robotics?
uh, I think AI is becoming a big part of robotics. I think AI is already in some sense a big part of robotics where I think a lot of sensing, vision based sensing, is based on AI. I think people are trying. I mean, there is a very small group of people who have started implementing AI on like trying to make a robot move or trying to make a robot walk. But I think we are still pretty far away from actually having AI being able to do that. But who knows? I think maybe in 4 years things might really pace up, and I think learning might start to work a lot more. But as of now, I think AI is mainly used for a lot of sensing, basically vision sensing stuff.
What software libraries are essential for robotics?
Uh, I would say software libraries. I think you guys should start with basic, like get yourself pretty good in Python or C++. I think even though Python is easier, I would still recommend if you can try doing C++ a bit more, because I think down the line a lot of companies still prefer C++ over Python today. But things might change. But I don't know. Right now, at least how the scene I saw was companies still prefer having C++ knowledge. So I think first of all, if you're really interested in software, making sure that you really know these two languages pretty well. And beyond that, I think there is something called ROS, or Robotics Operating System. I think once you're comfortable with C++ or Python, you can try giving a shot at ROS. ROS is basically like an architecture software that helps you like code up different algorithms and helps you connect different systems of a robot. Like if you have, as I said, like for to make a robot walk autonomously, you need at least five things. First is vision, where you know, like basically getting the sensing of where you are, what you're doing. And then from vision, it's like, oh, I need to do some planning stuff. I need to do some localization stuff to figure out where I am. Planning is to tell me where I have to go. And then the other thing is low level stack, which is like, oh, basically telling your walking algorithm, like giving the commands where it has to go. So I think passing information between all these different sub modules is what ROS is really good at, and it's helps making these implementation a lot easier. So I think at least I would say like C++, Python, ROS 2. If you know these stuff, like the other software libraries are like pretty easy to catch on.
And what are your most favorite and least favorite parts of being in robotics and
Uh, I think trying to solve difficult problems and figuring out like I think it was just seeing my robots do kind of cool stuff was always the thing for me.
what steps do you take when starting a new project?
So the steps that I usually take when I'm starting a new project is like figuring out what my end goal is for this project, like trying to plan, I'd say, timely goals, timely progress, and figuring out what those goals are and seeing if those are achievable or not.
Okay, guys, do we have any last questions you want to type in the chat? It's been about 30 minutes. Okay, if there are no more questions, then, oh, there's one more. Okay, how do you come up with your ideas for robotic projects?
So I think the ideas for robotic projects usually come from the problem. I think we try to look at a lot of our projects in the lab basically came from, oh, let's try to solve issues in the real world and see where people actually need robotics. And based on that, I think we try to come up with a robotic idea to figure out, oh, how should we solve this problem kind of thing.
Yeah, that is really interesting. Okay. Any last questions? Are your teachers hands-on with your work, or is it more like software based?
I mean, uh, are my teachers hand on is kind of a weird question, I guess. I don't know in what sense you do you mean that,
I think he
but I
means
think
like, what are you like doing more software or hardware in your job?
at least for me, I was a bit special. Like I entered as a hardware engineer, so I had experience as a hardware engineer, but I had a lot of interest in software. So I developed my software skills while in the lab, while I was still helping out with hardware stuff. But I think it again depends on your interest. Either if you're interested in hardware, like there's a lot of stuff you can do on hands-on hardware stuff. I think even software is, I would say, hands-on work because every time you write a new code, it's not just like sitting in a laptop and figuring out like most software companies. You have to go to the robot and like make sure your code runs well enough and like you don't break the robot. So I think in that sense, I think both software or hardware are hands-on work. As for, I don't know if you mean like are teachers hands-on with me, it depends, but I would say in very few cases, at least in like graduate programs, will you have your advisor or professor really being with you. I think everything is figuring out by yourself or having a team or a lab in which you have people that will help you around. I think it's just the group of people around you that matter, and I think that is a bit luck based. I was lucky that I did get it with a group of nice people who helped me a lot, and we all helped each other. But our advisor really never had that much time because he was pretty busy with all the stuff he had to do. So it's not like high school where a teacher might help you out a lot or like might be there with you. I think in graduate school, a lot of problem fixing or finding has to be done by yourself by using either Google or just like trying to read research papers or like books and finding and seeing if you can fix this problem.
Okay, is there any last words you want to say before we end the meeting? Okay, thank you, Mr. Aditya, for having the meeting today and
Yeah,
sharing
thank you.
knowledge about robotic engineering.
Yeah, I hope it was helpful.
Yes, it was really helpful. I will send this Zoom recording to you if you would like to look at it later. But yeah, thank
Yeah,
you again for having the meeting, even though there was a little mishap. Okay,
yeah, sorry for that.
that's okay. Thank you, everyone.
Thank you.